Now we'll start considering the debugging technique that we have with us when we considered the embedded system design with a Microblaze, right? So the first debugging technique, which is an hardware debugging technique that we'll consider, is an usage of an integrated logic analyzer, right? So in this specific video, we'll be understanding an entire process of how you probe an ILA to understand the transactions that are happening on a net, and then how you run an entire process to see the signal transitions on an ILA, right? So we started a new project and we already utilized the TCL script to create the fundamental block design, okay, that we've been using from the beginning of the course, right? Now what we're gonna do is we will be understanding the transaction that are happening within Gpio Ip, okay, and we will be analyzing them on an ILA window, right? So we go ahead and add a Gpio Ip. This is the first step that we do. Now we already have developed the code for a Gpio Ip. Okay, so what we're going to do is we will configure a Gpio Ip such that it help us to communicate the data to an LED, right? So to customize an IP, just double click on a Gpio Ip and then select LED 16-bit, right? And hit OK. Once this is done, you are just need to perform a connection automation, right? So once you perform a connection automation, this will automatically interface our Gpio Ip with an MXEDP port of a Microblaze, right? Now you have a Gpio Ip, okay, AXI interconnect and then MXEDP port, right? Now we'll try to add the debug probe, which are ILA probe, such that we able to analyze both the AXI transactions that are happening with the Gpio Ip and the output that we are getting on an Gpio output port, right? So this is the first net that we want to add in an ILA window, okay, so that we could analyze the values that we are sending on a Gpio. So just select the net, right click, and then you have a debug option, right? So this is the first step that we follow when you wish to add an ILA probe into your design, right? You just need to select the net and click debug, right? So you'll be finding a bug has been added on a net and you immediately get a connection automation. So here, if you perform a connection automation, this will automatically add system ILA block into your design, okay? But in a case, let us assume you want to mark more nets for a debugging, then for each net, if you immediately perform a connection automation, you will have different instances of a system ILA, and that is a bit difficult to handle. So first choice will be to select all the net, okay, which you wish to mark for a debug, and then perform a connection automation, right? So that is what we're going to do over here. So we mark our Gpio output for a debugging. Similarly, the AXI transaction that we are sending on an AXI Gpio, that is also we need to analyze. So we'll just select the net, right click and click debug, right? So once you finish marking the different net for a debugging, then you could perform connection automation, okay? So what that will do is this will create a single instance of an ILA and there are multiple slots. So for each slot, the number of nets that you mark for a debug, so each net will be getting a unique slot, and that will be very easy to analyze on an ILA, right? So here we selected all the nets that we want to mark for a debug, and then we perform a connection automation, right? So as you perform a connection automation, you will be getting an option to select all the nets that you want to add in a system ILA block, okay? So we will be selecting all the nets. So here you'll be finding the list of the nets that user have selected, and then you get an option how many of them you want to add into a system ILA. So the good choice will be that you select all the nets, okay, and then select data and trigger and proceed for creation of an system ILA instance, right? So now you could see if our connection automation is successful, you could see the system ILA block been added into our design, and then we have a multiple slot, right? So each slot will be assigned to the net that we have selected, right? So here we have marked 2 net for a debugging. So one of the slot is assigned to the output of a Gpio Ip, and other slot is assigned to an AXI transaction that we are sending on to the Gpio Ip, right? So this completes the block design. Now we will just be performing a validation of a design. So once validation is successful, okay, we will be counting the number of ports that we have in our design. So we have 1, 2, 3 and 4, right? So 4 ports are available, and if you go to the board tab, right, so you could clearly notice we have 1 check mark, 2 check mark, 3 and 4 check mark, right? So all the ports have been mapped to their respective hardware pin. So we proceed for generation of an HDL wrapper. So once wrapper is ready, okay, and if it is set as top module, we proceed for generation of a bitstream, right? Now here we are not performing an intermediate synthesis because all the ports that we have in our block design have been mapped to their respective hardware pin, right? So we'll wait till bitstream generation is successful and then we'll understand the rest of the procedure.